Hello and thanks for joining me. My name is Ulrich from www.plasmaspeaker.de. Hello guys. In this episode I like to show you a really old Corona plasma speaker. This is OEM version. It was not sold to an end user. It was made for several speaker manufacturers in Germany in the 70s and 80s. I have a pair of them here for repairing and upgrading. They are defect, and you hear is something is rattling. And this is the first of the pair, and you can see it with the serial number, which version it is. Normally the first three digits are the version 421, 424, 521, 524 is the version number, and the last three digits are the original serial number. This serial number begins with 216. I don't know if I can capture this here. So 216, so it was not an end user version, it was an OEM version for OEM manufacturing. Yeah. These things are defect, and this has to be taken to be apart. So, but I have taken apart the first one of the speakers, and I forgot to mention that these speakers have a separated power supply. So this power supply was separated, it was mounted in the speaker box, and the connection to our plasma speaker here was made with this short cable and with a tube socket. So this would make like this. So here we are. And this was the connection to the speaker. So for the power supply, there is nothing fancy in it. So it is a transformer. What you can here see is two relays, and these two relays switching the high power voltage to the speaker, and the little relay is switching the AF, so switching the speaker signal. So this is the input for the speaker signal. There is a fuse, and there goes two RF chokes to the switching relay. And here on the bottom you can see an operational amplifier. It has nothing to do with the loudspeaker signal. This is only the switching circuit for these relays. So this is switch power on delay, and automatic switch on off the speaker when the loudspeaker input signal is coming on. So it had nothing to do with sound, and it's only a switching. So, and there is not much to talk about this power supply. It has the main power input here, the transformer with two voltages. The first voltage is 230 volt for the speaker, for the Corona speaker, and 24 volts for the speaker signal and for the amplification. So these are a few resistors, so nothing special in here, only power supply. So I've already dismantled one of these speakers here. You can see this is horn. This is made out of aluminium, and on the back there is steatite ceramics with also a hole in it, and this is the housing for our plasma quartz cell. So this little guy here is the plasma cell, and then I have to look for, this is the original electrode. It comes in like this, and is sitting in there. So this is the housing for our plasma cell. And in the speaker itself you see here a PCB, where is the circuit for the RF generation, a big electrolytic cap, some little inductors, and of course the PL519. It's going in like this, and on the back there is here is the RF coil, and the RF coil is sitting here underneath that, and on top of this, with some spacing screws, there is another PCB. There is the modulation transformer here. This is the modulation transformer. There are some resistors, and this is the starting relay, and the loudspeaker input is coming here over this green wire, goes through these caps, and these caps to the modulation transformer, and the output of the modulation transformer is going in the second module, and all these is sitting here in two aluminium cages. There's one, and for shielding purposes there is a second one here, and this is the inside of these Corona loudspeakers. So I got this for repairing, restoration, and for upgrading. So what we will do is I will upgrade this to a bigger quartz cell. So here is the quartz cells I use. Took a pencil here. So these are the quartz cells I'm using. These are universal quartz cells. Here's the original. This is the original one, and this is the quartz cell I'm using. So the quartz cell I'm using is a multi-purpose quartz cell. It has a bore of 5 mm on one side and a bore of 6 mm on the other side, and it's symmetrical. So I can use this for older speakers with 5 mm quartz cells, and I can use it also on newer models which have 6 mm diameter in the quartz cell. And this quartz cell is symmetrical, so you can use it from both sides. If we put the electrode at this side, we have the output of the 6 mm out there. So we have a 6mm flame size, and if we put this on the other side, so there we have the 5mm bore, and then we have 5mm flame size. So the original quartz cell is here, and the original quartz cell is a 4mm quartz cell. So this is one of the first samples with 4mm flame size. And this is also the reason why these tweeters can only go down to 5 kHz or 6 kHz with these 4mm quartz cells. So also this quartz cell is damaged. I will show you these in a macro picture. There are cracks here in the front of the quartz cell, so it has to replace. The owner wants to upgrade it on a 6mm flame size. So this we will do. Yeah, this is the coil, and the coil was also damaged. Here the bottom was loose, and I have glued it with ceramic glue new together, but it's also damaged electrically. So the coil is wound with silver plated wire, and if you look here down, you can see that the silver plated wire is corroded. So there's a lot of corrosion on the silver plated wire on the first 1, 2, 3 windings, and this is really bad, because RF is only traveling outside of the windings. So RF is not traveling in the windings, because this is silver plated copper, and the reason is silver is good for the RF traveling, and therefore it's silver plated, and here is the silver corroded, so we have to wound this coil also new. They have to be rewound with new silver plated copper wire. Yes, also this electrolytic cap, you see underneath the electrolytic is blown out, was sitting here. I have already replaced it. And interesting is all these electrolytic cups are rated for 85 degrees Celsius, and I think in the tweeter cage it is hotter, so I replace these caps always with 105 degrees Celsius rated electrolytic caps. Now I just unsoldered the electrolytic cap and want to show you what we are measuring here. So this is the minus, the first cap, 1 microfarad, 1.5, 1.7, 1.5. To show you that the instrument is working, this is a Panasonic 100 microfarad, and here we are, 103. So this cap is totally dead. Yeah, unfortunately these caps are hard to get nowadays, so we will exchange them to more modern ones. Now this is the tube testing. It's an old tube tester from Eastern Germany, and we can check here if there are shorts, and we can also check if the tube is good, so it has to be in the green position. So now we are heating the tube, checking for shorts. So no shorts at all. And now we are testing the tube. So you see the tube is not in the green area, so the tube is also bad. Now we are checking the second one. So tube is heating. Now checking for shorts. No shorts. Oh, very slowly coming up. Bad. A little bit better than the other one, but yeah, it's coming up a little bit, but it's too bad for further uses. Okay. I would like to show you some close-ups from the quartz cell, which I found in the hardly damaged tweeter with the components defect, the Z diodes and resistors and so on. So this is the quartz cell, and this is the damage. Here is a high frequency hole. It goes from the outside to the inside where the electrode is in. So the electrode is in from this side, and here you can see that the RF has made a channel, a hole through the glass to the outside of the quartz cell, and there is the counter electrode. It is in this position, and now we have a channel from the electrode with high voltage through the quartz cell to this counter electrode, and this current, which is then coming from here to here, has damaged the part. So this damage of the quartz cell has damaged the tweeter. Yeah. So, and these are 4mm quartz cell, as I mentioned before. So put this on. This is the 4mm quartz cell, and the upgrade is I will put in this universal quartz cell, which I make. It has 6mm on the one end and has 5mm on the other end. And I'll put the camera a little bit higher. I think that makes it easier. There it is. So, and also the ceramic has normally a 4mm hole in. So if we put now the 5mm quartz cell in, we don't win. So we have to grind out this hole also to 5mm, which I have already done. Here it is. And to grind ceramics, I use these diamond drills. And with these diamond grinding drills, I can grind out on the lathe these ceramic. They are pretty expensive, and if I have grind 2 of these ceramics, so the diamonds on the outside here where the grinder goes in is damaged, so this grinder is not usable anymore on the tip. So to grind 2 of these ceramics, this grinder has gone. So this is so now we have here the ceramic with a 5mm hole. We have now the quartz cell with the 5mm hole. We can put in here, and we have also then the new electrode, which I can show you here. It has now a really nice tip. So these are the cells and the ceramic. Now the coils are ready. So the foot is glued on the ceramic, and the coils are sonically cleaned and new wound with silver plated copper wire. So now they are ready to put in. The tweeter is put together, and here you can see these are the new electrolytic caps instead of this old big one which was in here. So there are newer modern types, and the tube is replaced with a new old stock original Siemens PL549, and the coil is rewind, so there is new wire on, silver plated copper wire, and also the damaged part here in these power supplies are changed, and now it's time to switch on. So here is our power supply. It's the separated power supply. Tweeter is plugged in here, and yeah, I will dim this light here. Maybe then we can see better when it powers on. So switch is powered on, and the tube is heating, and if we are lucky, then the tweeter will turn on. Yes, tweeter turns on now, and I think you can see the purple flame here also in the back of the quartz cell. Maybe I can dim this other light. So this is the purple flame down there, and now I can turn on my function generator. Here we are. These are 2 kilohertz. Tweeter is loud and clear. 2 kilohertz, 2.5, 3, 3.5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 20. 20 I can't hear. But we're coming back here. So, the tweeter is upgraded to the 5mm quartz cell. So that means this is now a type 514, which is rated at about starting frequency 3.5 kilohertz, but what we can hear in the demonstration, it can go down to 2 kilohertz. So this is not a problem. Maybe the tweeter is not so loud on 2 kilohertz, but it's able to reproduce it. So now they are refurbished. All parts, all relevant parts are new. New quartz cells, no tube, no electrolytic condensers. I think it's ready for the next 5 to 10 years. So guys, we are on the end. The tweeters are finished, they are repaired, and they will get back to their owners. So this is the end of the episode. I hope you have enjoyed it, learned something, and see you next time. Bye.